Hey everyone, welcome to my channel. Today we are going to look at a programming problem. It's called Aggressive Cows. If you go to spotch.com and click on the list of classical problems and sort by quality, you would see that it's the most upvoted problem. So I'll let you guys read the problem for a moment. Pause if you want to try and solve it, and once you're back we will try to solve it together. Alright, so what does the problem say? So we have n stalls, and the stalls are located in a straight line, and we need to pick a barn layout, which means we need to pick C barns out of the n stalls to place the cows, so that the distance between any two of them is as large as possible. So essentially what we need to do is to maximize the minimum distance between two cows. Right, so what do we have here? We have this list of positions. It's 1, 4, 8, 2, 9. That's from the example in the problem, the toy example. And the output for this is 3. So let's see how we can get there. First we need to sort this. The sorted array looks like this. And then we need to define what a valid configuration is. The minimum possible answer here would be 1. That's basically the distance between any two stalls. These are essentially the positions in the straight line. So that's x equal to 1, x equal to 2, and so on. So let's say we have a minimum distance of 1. The max distance here would be basically the difference between the largest and the smallest, which is 9 minus 1, which is 8. So our answer should be between the range 1 and 8. So let's test for different values. And we will have a config here, which will be a valid config. Let's try 1. Now for 1, we can place the first cow without any loss of generality in the first stall. The second one can go here, and the third one could go in any of these places. Let's choose 4. So we have a valid config of 1, 2, and 4. Let's see what kind of config we get for 2. So 1. Now 2 is not possible because the difference between these two is 1, which is less than our value here. So 1 is possible, and then we have to go to 4. And then 8 minus 4 is 4, which is actually greater than 2. So we can also pick 8. So for a value of 2, we would have a config of 1, 4, and 8. Let's go on. Let's try 3. For 3, you can see that this config also satisfies 3. So in this case, the largest minimum value would actually be 3. For 4, 1 is definitely the first one, and then we need the next to be 5 or greater, and that's basically 8. The next has to be 13 or greater, but there are no more positions available. So 4 and beyond, we do not have any valid configurations for this arrangement of barns. Alright, so what are we looking at? We're looking at a function which is given a barn layout and a number of cows should give us like a Boolean value, which is either true or false, if there is a valid configuration possible or not. Right, so we can see from the toy example that the answer was 3. And for any number which is less than or equal to 3, we always have a valid configuration. And for any number which is greater than 3, we always have an invalid configuration. Right? So we can formulate our problem as a binary search problem. So we had to find an answer in the range of 1 and 8. We would search for the midpoint of this range, which is 4 here, and check if the midpoint is gives us a valid or an invalid configuration. So since 4 is greater than 3, we saw it and it gives us an invalid configuration. We can't find a valid configuration, so we have to look in the range of 1 and 4. So this was divided into 2 ranges, 1, 4, and 4, 8. Right, so this is completely excluded now, since we find that 4 gives us invalid, and anything greater than 4 is always invalid. All right, so in this case, the midpoint would be 2. And since 2 is valid, now this would be broken up into 1, 2, and 2, 4. So here, we are always looking for a larger value than 2, right? So since 2 is valid, we would look for a larger value. So we'll look here. And we keep going, we find 3, right? So this can be split into 2, 3, and 3, 4. We keep going. Since 3 is also valid, we look for a larger value. And then we find that 3 satisfies and 4 doesn't, so our answer is 3. So let's employ this strategy in code. All right, so try to write the function, which is the largest minimum distance. Okay. It returns an integer, which is an unsigned integer. Distance. So it takes a vector. Of the barn positions. They are also ints. I'm not making it a const because I need to sort this. All right. Here we take the other integer, which indicates the number of cows that we want to place in our barns. Right. So we need to sort the vector. So this is how we sort the positions in ascending order. So you have the two distances, the minimum distance and the maximum distance, which would be the difference between the farthest two points, positions. That would be position start back minus position start front. Alright. And we set our answer, which is the best distance, to 1. Should not miss the semicolons. So we run a loop until the range, which is max dist minus min dist, is greater than 1, because that's the minimum possible value. Right? And inside the loop, we compute the midpoint. That's what we do. Binary search. Binary means 2, so every iteration we split our range into 2 parts. Right, and risotto here. Mid dist would be half of the min dist and the max dist. So we just need to test the mid dist. Right. Let's keep this temporary variable, just the previous position that's used. So by default, without loss of generality, you can always place the first cow in the first position. Right. Then we loop over the remaining positions. Starting from 1 all the way up to the end. Right, so the next cow must be placed at least mid dist away. Right. So let me check the positions. And if the distance between the current position and the previous position is greater than or equal to mid dist, we can place our cow on the ith position. So we need a variable here. Let's say this variable. Let's make it a uint as well. Right, so the first cow is always placed. Then we change our previous position to the ith position. Now, at one point, if all the cows have been placed, which means if cows placed equals some cows, break. So once our loop is over, we just need to check if we place all the cows, right? If we manage to place all the cows, this is a success. And what this means is for our mid-dist, the value of mid-dist, we were able to place all the cows. So the answer must be greater than equal to mid-dist, because, you know, all values less than the answer should result in a successful configuration. So we search for a larger distance. Okay, so we set our min-dist. So we shift the range to the second half of the binary segment. So min-dist will be set to mid-dist, and our best dist, which we are maintaining, we will just take the max of this. So we keep updating our answer. If we were not successful, which means we failed, we were looking too far ahead, so we were looking for a much larger value, looking at a much larger value, so we should search in the first half of the range, the binary split. Search for a smaller distance, right? So we set our max dist to mid-dist. Okay, and basically that's it. That's all we need to do. So here, return our best dist. So that's our implementation. And now to write the main function. To basically, you know, feed in the input and output. So I have a string somewhere. Also need cstdint. All right. So the first input is the number of test cases. Let's use an int here. And this should work. Then we have two values. Let's use this as an int, because we're going to use the while loop. And read these two as well. Vector of positions. There would be n positions, so we reserve a memory of n. So just feed these in. right? We have the positions here, and now all we need to do is to call our function with the positions and the number of cows. And we output our answer. A mistake here. Right. Positions. There should be positions.size. Right. Let's go again. The input is this. Yeah. So let's submit our solution. We pick CPP 14. And here it goes. That looks good. Let's go. That's us. We just solved our first problem. So thanks very much, guys, and see you in the next one.